function isn't in our typical form written as a single rational expression. It's written in transformational form, which takes the parent function and shifts it horizontally and vertically. The vertical asymptote comes from the denominator. Set the denominator equal to 0 and solve for x. The horizontal asymptote is y equal 2. And to graph some points, we will plug in values. I'm going to plug in a value to the right of x equals 3. And I end up with 1 over 1, which is 1 plus 2. Follow the asymptotes. On the other side of the graph, I'll plug in a value to the left of x equals 3. 1 over negative 1 is negative 1 plus 2. And that graph is the same exact shape as parent function, except it was shifted to the right 3 and up 2. The domain goes from negative infinity to the vertical, excluding the vertical asymptote, and the range, we exclude the horizontal asymptote. Transformational form, the vertical asymptote is x equal negative 2. And the vertical asymptote, y equal negative 4. Extended those a little bit more now that I see they're falling off the graph. To find some values, I can plug in a number or two to the right of x equals negative 2. How about plugging in a negative 1? That gives me 3 minus 4. If I plug in a positive 1, 3 divided by 3 is 1 minus 4. Ooh, I got lucky with those choices. On the left side, I'll plug in, how about a negative 1 and a negative, not negative 1, I need to count from to the left of negative 2, I meant to say negative 3 and negative 5. Plugging in a negative 3 gives me 3 divided by negative 1. That's negative 3 minus 4. Uh-oh. I'm working in my graphing space. I think this will work. Plug in a negative 5. 3 divided by negative 3 is negative 1 minus 4. And connect the dots. You should notice some symmetry with the amount of space the points are from the intersection of the asymptotes. Domain negative infinity to the vertical, vertical to infinity. Range negative infinity to horizontal, horizontal to infinity.